Alrighty, welcome back, and in this tutorial we are going to start working on the task that I assigned you in the last time. So yeah, we need to declare variables that is going to store the maximum and minimum boundary of the player's movement area. So what does that mean? So if this is the screen, um, we have the left boundary that starts from here, right? We have the right boundary that starts from or ends in here. We have a top one that goes somewhere in here, and we have a bottom one that is somewhere in here. So basically we just need to have four variables, right? So the maximum x and minimum x, and similarly maximum y and minimum y. So yeah, so let's declare the variables. So the boundary should be a floating point number, right? Because the screen positions can be pretty precise. So we're just going to create a floating variable, public float min x, public float max x. Again, public float min y and public float max y. Awesome. Now let's go back to Unity and see what have we got. If I now click on the player, you can see we have a max x, min x, max x, min y, max y. Although the spelling is not correct. Awesome. Yeah. Now we need to put some values in here. What value should we put here? Let's take this player and let's move it to check what is the boundary for the player should be. So if I move the player to the very left, this is the minimum x that the player can travel, right? So if I look into the position in x from my transform, we can see that the position is minus 9.4. And if I move my player to the right most corner, is plus 9.4. So I can say that the minimum is minus 9.5, right? And the maximum is plus 9.5 in x direction. So I can do something like this. I could do minus 9.5 and in the max 9.5. Easy, right? And similarly for the y, we are already in the minimum y location, so the minimum y can be minus 4.49, and if I move up, we can see the maximum can be 4.5. So again, the minimum can be minus 4.5, right? And the maximum can be plus 4.5. Right, so we could do something like this. Minimum should be minus 4.5, maximum should be 4.5. So now that we have all the boundaries set up, the next thing that we want to do is add some logic into our player script. So whenever the player try to move, if it moves outside that range, we should stop it. We should not let the player move, right? How should we do that? So let's try to figure it out with a simple English conversation. All right, so this is what I'm trying to say. I'm trying to say, if my player is not traveling outside the maximum x, we should keep it moving, right? Or if my player is not going beyond this point, we should keep moving it. All right, so we can see that this is basically a condition, right? So this movement should only happen if and only if my player is inside this bound. So when it comes to this sort of conditionals, we use the conditional blocks of C#. So let's first of all look into the syntax of conditionals. So I am just going to again start with this start method, and we are going to just see how this if conditional work. So I'm going to say if, and then I should start this first bracket. All right, inside the first bracket I'm going to do the condition, and here I should have a body. Okay, what is a condition? So I am going to write down a condition here inside this first bracket, and if that condition is true, only then the body should execute. All right, everything that you write here. For example, I'm just going to write speed, just going to print speed based on some condition. Now what should be the condition? Remember, quite a few class earlier we talked about boolean type, true or false, right? So just I have just mentioned that this condition can be either true or false, right? So if the condition is true, then we are going to execute the body. Okay, if that is not true, this is not going to do anything. For example, let's see, I am just going to do something like this. If the players transform dot position dot say x, right, yx, I'm just going to first do this. If this is less than max x, what does that mean? I'm just going to keep it side by side so you guys can understand this. It's compiling. All right, so yeah, let's see this. What we are trying to say here is that if the player's position, which can be determined by these values, if the position in x is less than maximum x, the value of maximum x is 9.5. So what we are trying to say, if the player's x position is less than maximum x, then print speed, right? As you can see, the position currently is minus 0.02 and the maximum is 9.5. Obviously the current position is smaller than the max x. So if I run this game now, I'm hoping that we should see a value, and indeed we see the value 15. If I stop the game and run again, right, so we can see that is happening. So let's try it the other way. If I try to do something like this, if max position dot x is bigger than max x, so what does that mean? That means we are now trying to check that if the player's current position in x axis is bigger than max x. Okay, let's see, the player's current position is minus 0.02 and the max is 9.5. So obviously that's not true. So let's see what happens. Nothing gets printed out. So that means because this condition was false, this block did not get executed, right? So long story short, this block of code should only execute if this portion of code is true. Okay, so I'm just going to do this again, and now what I'm going to do, I am going to add one more condition, because see, we want to just print this speed if the player is in here in the bound, right? So what does that mean? That means the player's current position is bigger than the minimum x and less than the maximum x, right? I hope that makes sense. Only in this condition the player should like move. That is what we are trying to do. So yeah, so let's try to see how can we merge these two conditions. So again, what was our condition? Our condition is that if the player's current position is bigger than the minimum x, right, and smaller than maximum x. So two condition, and we are using an AND, which is important. So we're just going to say if the player's position dot x is smaller than maximum x, and right, so this is how you write AND, a double AND sign, and then transform dot position dot x is bigger than min x. Okay, so let's try to understand this line one more time. So we are adding two condition 1, condition 2, using a AND. So when we are using AND, that means both left side of this AND and the right side of this AND has to be true. Okay, so in AND we have to make sure like this is basically true. I'm just going to do A and B is true only if A equal true and B equal true. Other than that, it should always be false. Okay, if either of them are false, if A is false or B is false, if both of them false, in all the other cases it should return false, right? So let's see if it should actually print the value for our case. So our player is currently in, I'm just going to make it 0, in 0 position, and the value that we're looking for here, we're looking for if the position is smaller than max x. 0 is smaller than 9.5 and 0 is bigger than minus 9.5. So yes, this condition is true, so it should print the speed, and indeed it prints the speed. Awesome. So now let's try to copy this part and let's put it here. What does this should do? What is your guess? Pause the video here and think about what just I did, and think about if you could figure it out by your own, and then come back and I'll talk about the answer. All right, so yeah, so what did I just do? So here I am just saying that if the player's current position is smaller than max x and bigger than the min x, only then the player can move. So let's see. If I now play this game, I'm just going to move it right side, and now even if I'm trying to move right, it's not moving, right? So the reason behind that is now the condition has become false, right? So it's not letting me move anymore, right? So if I try to move left, you can see I cannot move left anymore. So yeah, so what I want you to do next is try to figure out how can we make it so that if the player is trying to move up or move down, when it goes outside this bound, we don't allow it to do that. All right, and there is one problem that we're going to fix in the next class, which is when I'm trying to go right after this point, if I try to go left, it's not letting me to do that. So we're going to fix that in the next lecture. Till then, take care, and also make sure you do the task for this lecture, which is try to make this thing lock if it goes outside the y bound. I'll see you in the next lecture.